This is the Earth Science Classroom. Welcome back to the channel. This video is on exfoliation. Now, exfoliation is a type of mechanical weathering. You may see this also called physical weathering, and it is a type whereby thin slabs or sections of rock are peeled off, okay, either in what's called sheets or what's called sheeting, and this happens over a period of time in usually granitic rocks exposed to the elements. So it's going to cover how this happens. We're going to look at different types and patterns that this can also occur in. We'll look at exfoliation domes, okay, like this one right here, half dome in Yosemite, it's beautiful. And we're going to look at the relationships and connections between other methods of weathering, both mechanical and chemical, and erosion, how they work together, how they concurrently work on the rock to break it down and then transport it to new locations. So how does exfoliation happen? Well, you have a piece of rock, okay? Let's say you have a piece of rock, and let's say it is, here's the surface of the Earth. Here's the crust. So you have crust and lithosphere. Okay. And let's just use this purple, and here is my rock. Let's say it is a granite batholith. Okay, so batholith is a large area, usually around 100 kilometers squared or above. All right, which is cooled magma. So it's intrusive igneous rock, therefore granite is one of the main common types, and it is cooled and formed underground. Now you have your regular layers of soil and bedrock, maybe some sedimentary rocks here, maybe some metamorphic rocks, maybe some contact metamorphism around the granite as it cooled, maybe, but you have this rock. Now, currently it's underground, so it's not exposed to the elements, okay, just obviously the surface layer is. However, if you do get some sort of tectonic compression or compressional or tensional stress applied through, let's say, tectonics, maybe a convergent plate boundary, maybe just uplift like the certain plateaus like Colorado Plateau, and you get uplift. And over time, this granite batholith now comes above the surface. So now we have this batholith now, which is now part of the surface relief, the terrain, and it is above the prehistoric surface level, and now is exposed to the elements. So what happens is, once you have this layer, it's called overburden. It's that layer of material above the rock in question, which is the granite, which has been removed. So we're looking at erosion here with some sort of agent of erosion. Maybe it was ice, maybe it was water, okay, maybe it was added in wind as well. But the overburden mass has been removed. Therefore, we get what's called a pressure release. Obviously, with the granite being underground and under a certain amount of rock and material, there is gravity acting upon it, so it adds pressure on the granite. But now the granite is in the atmosphere, which is atmospheric pressure, ATM, okay, which is 14.6 pounds per square inch or psi. Okay, so it's much less pressure, so now everything is kind of like a rebound where it starts to expand. Plus, it's exposed to the elements and the sunshine, so we get the expansion and contraction that we expect from thermal conditions, or the influx of thermal energy, both day and night and seasons. So what happens is, with all this process going on, the overburden, which also can be called unloading. So you're unloading what's above the rock, allowing it to basically increase in size and volume and have that expansion. And what happens is, both on the compressional and tensional strength, usually it's tensional strength, so it's tensile stress, force applied to the rock, which will cause the rock to start to break. So this has actually gone through what's called exhumation. So it's been brought up to the surface, okay, and now the elements act upon it. So what happens is, after all the different elements, the stress, as I put over here with the different key terms, all right, is the top layer starts to undergo the stresses and starts to fracture, okay, and fracture equals break. There's a break in the rock. It's no longer solid rock. It's now in sections and pieces which can be measured by their size, and the fractures and faults can be at a certain length, and this is called pattern. So the fractures can create patterns in the rock layers. Now, what happens is there is the peeling off of these, let's say, slabs of rock on the surface, and they slab off and they're kind of like parallel to the ground, and with the fractures they start to move because of the tensile stress plus gravity, and they start to be pulled apart, and they kind of peel off like layers of an onion, or the orange peel when you peel it off an orange. So it starts to peel off, and you get these kind of like disjointed surface where it's like uneven. So this picture right here is showing you again the slope and the gradient will have an effect on this, obviously with gravity, but you'll see these bits here, these areas here, little slabs, these kind of like areas of granite that have been peeling off and flowing down, kind of basically part of mass wasting or mass movement, but slowly moving down the hill or the slope. And they form concentric slabs. So concentric means that it's going around a central point. So around the center of the rock, on the edge, it's going around. So what this happens is, what you get is these joints that are created. They're called exfoliation joints. And joints are basically a larger version of a fracture that extends further into the rock, but there's no movement either side. It's just simply a break in the rock. So what we have is these joints which are parallel, and under, let's say, thermo, which is heat, elastic, which is the movement in the rock, strain, which is the effect of stress on the rock, you get these slabs peeling off and breaking down this granite as it's exposed to the elements. Different types. Now, you have exfoliation domes. Now, different types. You have exfoliation domes, which is simply, rather than, it's a non-flat terrain. Obviously, it is the example I've shown with the exhumed batholith that was being brought to the surface, which is a big dome, right? And the layers start to peel off on the top. However, it does happen where you have more of a plateau or a flat surface where this granitic, intrusive igneous rock is exposed to the elements and can have exfoliation occur on the surface layers. Now, this will be not as dramatic and not as obvious as, let's say, an area that has a very steep slope, which is on the picture on the right hand side, which is a dome, but still can happen with this. Now, the cool thing is we can connect the weathering. So obviously exfoliation is a type of mechanical or physical weathering. However, other types are going to act concurrently, so at the same time, on this exposed granite slab or rock. So you have the thermal expansion, you have the compression stress and the tensile stress through different tectonics. You also have maybe abrasion, maybe wave action, depends on the time, geologic history, where it is. So you have all these things working together. Plus, you have the chemical weathering. So once these fractures or these exfoliation joints or joint sets are formed, these conjoined elongated fractures are joined up, then you're going to have a lot of access to the inside of the rock for any kind of salt wedging, any kind of freeze-thaw, any kind of hydrolysis, with the breakdown of just simple water over time with the granite. Now, granite does break down because the feldspar in the granite, the mineral, does turn to clay when exposed to water over a long period of time. So that clay is going to basically dissolve into solution and then leave the granite rock very compromised for its structure, both chemically and physically, its structure, and it'll start to break down. But the slab's going to work first in terms of movement. But the cracks are going to enable more and more weathering and chemical weathering to happen. And then plus we can look at the different types of erosion based on the location, the climate, the elevation, the relief, the precipitation, the erosion, the transportation of those weathered materials to a new location is also part of the whole system. And that erosion can remove these slabs, and then more layers underneath will be exposed to the elements, and it will continue. So this big cycle of weathering and erosion will continue on this piece of granite until it's weathered away, or until there's more tectonics to push it up further and to build that mountain, which is orogeny. And a beautiful example in Yosemite National Park, United States, is Half Dome. This huge large granite batholith in the park has extensive and very visible exfoliation joints and exfoliation of the upper layer, the top layer of the granite slabs peeling off over time. You actually hike up there and see for yourself the beautiful patterns of exfoliation and all the joints and joint sets that are going to eventually break this large, kind of exposed granite down to smaller area, smaller volume, unless there's any kind of tectonics to rebuild it. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel, and don't forget to subscribe. Thank you again.